So yeah, if you write a very simple program like this, then you can go ahead and run it. So
Okay.
run. So it runs the program. You can see some of the print statements, and then when you debug it, what you do is you say debug, and then you pass the debug command the history file. Because when you run the program, that generates a history file. So when you debug based on the history file. And and you have this debugger where you can step through the lines. You can see the variable on the side updating. You can step backwards. In terms of the keystrokes, I'm still like thinking about what are the best keystrokes. I wanted to use up arrow and down arrow, but for some reason, in the way that terminal programming works using the terminal emulators, I'm not able to get the up and down arrow with the control and alt modifiers. Like somehow I can't detect the control and alt modifiers if I use up and down arrows. So I resorted to using letter keys. So right now I'm using the letter keys I and K, because I and K is like up and down. I is like at the top row and K is right under the I in the middle row of the keyboard. Well, this one doesn't have any function calls that you can drill down to, but this is just a very straightforward, you step through the code. Let's just do the Fibonacci example. So if we run this, so this is the standard Fibonacci example. If we run this, it runs the program and generated the history file, and if you want to debug, then you can debug the history file. And this one looks like this. If you just say down, which on the keyboard is the letter K, then it by default it's step over, so it steps over that line. But if you want to step into the function call, then you would hold control and then press down, and now you get to step into the function call. And notice one big difference between this debugger and normal debuggers, conventional debuggers, is that after you went too far, you can just go backwards and then go again. And that makes a huge difference in the user experience, actually. So you can keep stepping. If you want to step in, you can step in, but if you don't want to step in, you can just step over it, and then you can see the results of those two calls. It's 3 and 2. And then when you get a return statement, you step over it, you will be able to see what the return value was here.
How would it look like when there are like multiple like frames opening?
Okay, I'll show you that. So if you want to see the multiple frames, then you just drill down again, right? So I hold down Control and then down, and then I'm drilled down to that call. And on the stack frame, you can see the state of the stack frame, right? So now there's 2 fib frames, and in each one, there's the parameter that was passed into the function. You can see that right away, and also the current state of the variables as well. And I do that again. I do Control down, and again, that's the 3rd level now.
That's nice.
Yeah. Okay. So now at this point, n is equal to 3. This probably should be n equals 1 or 2, but I had it 0 and 1. I guess I'm using 0-based indexing. I guess that's fine too. And then at this point, I am at 2, and then now finally I'm at 1. I'm gonna return this 1 here, right? So at this point, when I return 1, it says the return value is 1, and then it's gonna pop this frame at the top here, and then we're back to this frame, and then at this point n is 2, and we step to the next line, and fib1 contains the return value of that last call. Yep, so this is how you can see that kind of thing. So now I wanted to do like a programming problem from LeetCode that is sufficiently complex that will for sure make a mistake somewhere along the way.
Oh, so you asked whether we could use this in like a real debugging situation.
Yep.
Gotcha.
Yeah, I'll show you what it's like coding with this, because it is quite a difference from how you normally do it. There's one problem that I like: add 2 numbers, one with a linked list. I've done that one before, where it's kind of complex and it's based on linked lists. Basically, you have these numbers that are encoded in linked lists, encoded as linked lists, and so it's in the reverse order. Each node of the linked list is 1 digit in the number that you're going to be adding, and it's in reverse order, as in this number is actually 342. And this one is actually 465. So the linked list of 243 is actually representing the number 342. And then so what we want the output to be is a linked list of the exact same format. Well, this is actually difficult. This might take us a while to do, but let's try it anyway.
Of a simpler case, or say like if we don't have to go to like the next number or whatever, I don't know.
If you don't have to carry over. So the first thing I do with this programming language is always define a main function, and then since this is a linked list, so I have been doing this kind of factory function that takes 2 values, and then it returns a dictionary that represents the structure, like that. So very much like JavaScript at this point. So I call a list node, and it creates a list node for me. So if I want 243, then I would probably do something. Oh, by the way, I have we might encounter something where the debugger has a bug, because it's in active development right now. So either sometimes the language has a bug or the debugger has a bug, and if that happens, we might have to come up with a different plan. So one of the known bugs of this language right now is it kind of chokes when you have multiple nested function calls within another one. It kind of like if you have something like that, it kind of chokes. So I'm gonna try to avoid that for now, so that we can get past this. So I'm gonna do it on separate lines. This is 4, and it links to 3, and then I have a 2, and it 2 links to 4. Oh no, 2 is the value, and it links to 4. Okay, so this is the first number. So
there's on the list node on line 11.
Yeah, I'll say num1 is the one that starts with 2. Okay, so this is 423, which means 342. That's num1. And let's go ahead with the same thing. Oh, you know what? I'm gonna do it like this. so that I can use the same number variable name. Okay, so this is num1. Let's get num2. Num2 starts with 4, 6, 5. Okay. So I'll say make num1 and make num2. Okay. Okay, I'm just gonna run this to see if I made that right.
Sure.
Okay. So line 17. Oh, I didn't. I messed up. I didn't update these lines. So what I want is 4, 6, and then 5. 4, 6, and then 5. 6 links to 4 and 5 links to 6. So that's what I want.
Yeah.
List not. Okay, I misspelled it. Oh, this is actually a runtime error. And I want to show you one thing, is that if there's a runtime error like this, you can actually still debug this.
Okay.
As long as there's not a syntax error, you can actually debug this. And this is actually the location where, well, oh, I see what's going on. Okay. In the future, I want to add the feature to this debugger where whenever there's an exception, it'll show you the line where the exception happened, and then and then the debugger will, when you open the debugger, it'll immediately go to that line. If we had that feature, that could help us sort of narrow down that problem as well.
Yeah.
Do I have another one that's like that? Yep.
Oh.
And I just want to verify that the lists are what we expect them to be. So I just executed both of them, and you can see the structure is like these nested objects, and we can inspect them to see if they're right. They look right to me. These.
Okay.
5, 6, 4. Yeah, in reality, linked lists are nested structures. Maybe people don't think of them that way because in computer science they draw them like these chains of nodes. Sure. But yeah, they can also be thought of as these nested structures. Okay, so now that we have this, let's make the add to numbers function. How are we going to do this? And yeah, let's not worry about the carryover. Let's do the other part first, though. Like, so if we're gonna do, like, obviously if we sort of traverse through both of the linked lists at the same time, then we're gonna first encounter sort of the in the number is actually the rightmost digit first, right. Which makes sense because we want to add starting at the rightmost digit.
Right. Exact.
So that makes sense. So like the first thing you probably do is you grab the value out like this. By the way, I don't have dot notation in this language for now. So you have to do it like this, like the subscript notation.
How do I know the syntax of the language when I'm playing around with it
myself? Okay, you can look at the other examples. Okay. If there's a syntax problem, what would happen is it'll give you a sometimes very verbose syntax error, like that. And what you do is you scroll all the way up to the top, and it'll actually point an arrow at the location where it got confused. and it'll tell you unexpected something. In this case, it's unexpected NL, which stands for new line. Unexpected new line because instead I was not expecting to see a new line. Instead, I was expecting to see one of the following, either a white space or an open bracket. So you can, in this case, you can use that as a hint. Oh, maybe I needed a bracket here.
Okay, gotcha.
So reading the syntax error message will often help. Sometimes this output gets extremely long. Don't get intimidated. Just scroll to the top and read this error message. So I'm thinking maybe grab the values out of these nodes first. We do have to worry about like the null cases, right? When do we stop? But I'm thinking like digit 1. Grab the value out of the first one. Grab the value out of the second one. num1 and num2. And add them together. Result digit.
Sure.
And then we're gonna probably want let me think.
Are you gonna create a new linked list just to represent the result?
Yeah, we need to. That might actually be tricky. So screen.
Okay.
Let me try to see this. So 2 plus 5 to get 7, and we're gonna want to make a 7 node, and then later on we're gonna want this 7 node to point to the next digit later, right?
Yeah. Okay.
And that's actually slightly tricky because
First, the linked list is that the problem because we need to do the reverse.
Oh, you're saying like just build it, because the natural way of building up a linked list is you just, as you're building it, you point to the node that you already created.
Yeah.
So then after you do that, you reverse the linked list.
Yeah.
We could do that.
Probably a different way to do this.
Yeah, there's a different way to do it. But yeah, let's just go with that. Let's just have it be reversed first, and then we'll worry about what to do with it afterwards. Okay. So our result digit node is gonna be list node of. I'll just inline this here. Okay, and then what are we gonna do? We'll need to remember this for the subsequent call, right? So I think we need to pass it in as a parameter to our function.
Yeah.
So probably then we're gonna do that. Like that, and this is like the incoming, the results so far. We probably want to somehow, if there is a result so far, we want to mix it with this guy, don't we? Somehow. How do we do that?
So do we need to like return anything here?
Oh yeah, we want to return probably whatever this guy returns. Oh, well, that would be infinite recursion. But I think so though. I think yeah. But we need to write the code to stop to be the terminal case to be. And I think those are like null checks for these two nodes, right?
Yeah, I think probably what we need to do is in the line 25, when you call list node, we should have 2 parameters, right? So is it like digit 1 plus digit 2, and then the second parameter will be the add 2 numbers inside.
Oh, you want to stick this in here.
Yeah. Well, we need two parameters. So,
Yeah, you're right. Yeah, so what should go in here? I was thinking it might be this one, but you're saying
okay.
it's
I'm not sure.
we could let's see.
That's what the debugger will help us.
Oh yeah. so like if maybe we need to think about, hey, what are we gonna say that when add two numbers returns a thing, what should that thing represent, right?
Yeah, exactly.
Well, based on the problem, the thing should represent the resulting number, or the linked list that represents the resulting number, right? And if you are correct, then we're saying the resulting number from adding the rest of the digit should be linked to this digit. I think that's right. Yeah, let's go with that. Do we need to, in that case, do we even need this? We may not need the third parameter in this function. Let's just see what happens if this happens. We have not considered the terminal case though, so let's still try running it.
So it's gonna blow up if it's like what do you call it? Like a infinite thing. Infinite.
Oh, we didn't call the function yet. Let's call the function. Num1, num2, result. Okay, let's run this. Can I read property value of null? So let's debug.
Okay.
So where did it try to read property value of null? Oh, that's that one. That one sort of skipped to the end because there was an exception. So
Okay.
and you can see from the debugger that num1 and num2 are null. So you're trying to read the value from a null value. Read a property from a null value.
Because next is null. Okay, gotcha.
So this guy is null, and that was the one that was passed in as this num1. So now this is null. So what should we do about that?
Well, that's a terminal, right?
Let's check for null.
We should cover it.
So if num1 is null. Now there could be a case of, well, in this case, both of them happen to be null. What if one of them is null and the other one isn't? What do we do?
Oh, so they have different digits.
So like if one of them has 3 digits, when the other one has 2 digits, 3, 2, 1, then let's see.
Then you want to just add.
I think the 1 and 2 end up lining up. 1 gets lined up with the 3. 2 gets lined up with the 2, and then 1 on the second list you have a node, but the first list you don't have a node. So the first one is gonna be a null here. And the opposite could happen. It could be the other list has a null.
So when one of the stuff has a null, what should we do?
What should we do under the rules of addition? What should we do?
What do we do? We just add the rest of up, right?
Just add the rest of the other digit up, which is, well, there's only one digit, so there's nothing to do. Just use that digit in the result, right? Yeah.
The digit, yeah.
Yep. Okay.
But what if you have multiple digits? Then we have to use, well, I guess we can just run through all the remaining digits. Like if one number has like 3 more digits than the other number, then we have to go through the remaining digits.
Yes.
And put it.
Yeah, and in each case, pair a null with that node.
Yeah.
You still have to run through all of the digits. Yeah.
Yeah.
So maybe we go case by case. So if num1 is null and num2 is also null, else if num1 is null,
okay,
then what should we do? Else if num2 is null, then what should we do? Else is this case. Okay, what about the first case? What should we do? If both of them are null,
then just return. Well,
return what?
Wait, what do you return in this case?
Should return an empty list because, right?
Okay.
So that's what represents the end of the list. So an empty list is a null.
Okay.
So what about if 1 is null but 2 is not null? What do we do there?
We go through the remaining digit in the number 2.
So we recursively call ourselves. Okay. So I'm gonna mimic this one. So but num1 is null. So we're probably just gonna put null here. And then num2. Oh, except that we want to grab. We still need to do this stuff.
Oh, that's true.
Grab the digit out of num2, and then afterwards do that. Is that right? Oh, that should return that one. But here it's just there's no addition needed. We're just gonna put digit 2 here.
Okay.
I think. And then here is just the reverse, I think.
Yeah. Will the debugger help us to see which branch of the if statement we're in?
Yeah.
Yeah, okay, that would be.
Okay, let's see if this works. So we're gonna run it. Okay, so let's see. So in the first step, yeah, it's gonna take, for our case, it's gonna take the else branch until the very end. And then it's gonna take, it's just gonna take this branch. We won't hit the middle 2 branches for our case. So now you can sort of short-circuit it by just stepping over this and to see what the result was. And in this case, it's said 10 and 7. Is that correct? And I guess we're gonna. It says the result is 7, 10, and 7 is the end result. 7, 10, 7, 0, and 8. Oh, we haven't done the carry, but other than that, I think this is actually correct because 3 plus 4 is 7, 4 plus 6 is 10, and 2 plus 5 is 7. So I think the result is correct. And yeah, the result is 7, 10, and 7. If we had done the carry, it would have been correct.
Okay.
But we could step through it in more detail to see what actually happened. So you can see on the frame we have the first frame that calls add two numbers has num1 starting at 2, num2 starting at 5, and then the next frame is dealing with 4 and 6, and then the top frame is dealing with 3 and 4. So the top frame.
What is the star?
Oh, the star. The star is a reference to an object on the heap. Is basically what it is.
Okay.
I did this feature in a hurry. If I were to render the entire object on here, it would be very long, sort of like this. And I didn't want to put that very long string in this header here. So I just put the reference number to the heap object. So, but that doesn't tell you all that much. but yeah, if you want to see the actual value of num1, it's actually down here, because.
Gotcha.
Mm-hmm. Okay, so now that we got here, it makes one more call with the null values, and at this top stack is now null, and we can see we have 4 stacks for this add two numbers function, and at this point we're gonna return null. There it is, and then this is gonna return back with this result of null here. And then we're gonna make a list node here. We're gonna make a list node here, adding the 2 digits. And oops, that's a bug. That's a bug in the debugger. But ignore that. When I was scrolling left and right, and then I moved the cursor, then that line get rendered out of alignment with the rest of the lines.
Oh, okay.
So that's a bug in the debugger. So I'll scroll back over there. And
wait, question.
Yeah.
What's the language that you use to write the debugger, like the terminal stuff, like the UI, like this?
Yeah. So. Yeah, that's actually very interesting. It's the terminal protocol. It's partly historical and partly standard. Goes back to Unix, where it used to be we didn't have graphics programming we have today, and people only did terminal text-based programming. There's a lot of user interfaces written using text-only terminals. And so in order to do anything interesting, you needed the ability to tell the terminal, hey, draw this thing at this cursor location and stuff like that. So the terminal actually has the ability to let you do that. There's special escape codes that are almost like, you can think of them like tags. You put the terminal into this raw mode, and then you tell the terminal, hey, draw this text at this coordinate location of the screen.
Oh, interesting. Is that so that's a special language?
It's a language in a sense, but it's a protocol that you send special control codes to the terminal. This debugger is written using JavaScript, Node.js, and this is what the control code looks like. For example, this /x1b, also known as /033, they mean the same thing. Most of the terminal control codes start with this control character, which if you printed this out, you can't see it. That's how colors work as well, by the way. Let me show you. So if you do console.log hello world, then you print hello world. But if you put in a control code for a color, so Node.js has these packages called chalk, for example.
I remember we used it in the bootcamp.
In the bootcamp you can use there's a colors module or a chalk module, which will put in these control codes for you without you having to know what they are. So you can install chalk require chalk, and then chalk.blue, and it'll add the control code to make that text blue. But it's actually not that complicated to know what, like, this is.
Okay.
This is the control code for red, for example. So let's try that. It's bracket 1 semicolon 31M, and now that text is red, right? And then I think that persists.
Oh, you need to set it back.
Yeah, there's a. Oh no, it doesn't persist. I was expecting it to persist because there's also a reset control code to make that setting you just put in go away. But I don't know. Maybe with console.log it somehow resets. So the colors are the simplest kind of control codes, but there's also control codes that are like go to this location on the screen, which is this one. So like you can say, hey, I wanna go to location, say, how big is this terminal right now? Like 10, 20, 30, 40. I think 40 is around here, maybe. So I'm gonna print it at 41. It's actually a semicolon. And then I put F here. So that moves the cursor to that coordinate. And then and I'm gonna write hello world. Does that work? No. I was expecting that to work. Oh, I didn't put it in raw mode. That's the problem. I need to put the program in raw mode, and it will work.
Raw.
So here, I set the standard input to raw mode, and then all of these other control codes become active. And there's also even mouse button tracking. You can actually get mouse events as well. And that's which I only learned about like last week, which is what allows me to do this kind of scrolling here. See, I can do scrolling.
Pretty cool.
I can do scrolling on the left panel, and I can do scrolling on the right panel, and I can program that.
So you write the scrolling functionality pretty much yourself.
Exactly. I'm getting the raw mouse event. In this case, it's the scroll wheel event from the mouse.
Okay.
And then I'm looking at what is the position of the pointer right now, where the scroll wheel event is coming in, and then I map that to figure out whether it's on the left panel or the right panel. And therefore, I'm going to scroll either the left panel or the right panel up and down. So yeah, all of this UI, I wrote all of this in probably the last few weeks. And it's pretty fun. It was pretty fun learning how to do all of this. But yes, you can actually write pretty nice UIs. I don't know. I like terminals.
I think it's really cool.
Yeah, definitely. Let's get back to solving this. So at this point, so if we step through this line here, then we can see the result digit node is 7.
Okay.
And the next is null. I think that makes sense. Like we added 3 and 4 together, and now we just get a linked list that just has a 7 in it. And then we go to so we pop that stack. So then the result here is what we saw, is the 7 list. And then but we're gonna here we're gonna add these 2 digits together, the 4 and 6 together, to make another list node, and then join it to the 7 here. So the 7 this 7 from here is gonna go after this 4 and 6. This, I think that's actually in the right order, actually.
Wait, what is the final order?
Because we added 4 and 3, the rightmost 2 digits first, and then after we done that, after we done that, we got a 7. And the 7 is the thing that we want to append to the result of adding 4 and 6. So we get so 10. Well, we're supposed to carry the 1 over, but right now we haven't. And we're saying, hey, append this 10 here, this 10 that we're gonna get, its next value. Okay. Its next value is this 7.
Right.
So this is the correct order in which we're linking together these things. And then we're gonna end up, and then this should be read, to interpret the real number, it should be read from backwards.
So
we're almost there, except for the carryover. We have to get the carryover correct.
Just add in the recursive function. Just say carry over. It will carry over.
Just say carryover. Add a parameter that says carryover. Okay.
Yeah.
Let's try that. So
because it's either or not carry over.
So when we add, let me think. When we carry over, though, we actually might need to return a parameter, return an extra value to tell whoever called you to carry over, because when we're in here,
okay, I see.
Because of the order of things, right? You want, after you have done this step here, we've got 10 and 7, and then it's a whoever called us. When we go back to the previous stack frame, we want that code to add 1 to their digit. So I think we might, instead of adding a input parameter, we might need to add an output parameter. So maybe what we do is have this return 2 things instead of 1 thing. And the way Python has really good feature for doing this, this language doesn't at the moment. So I'm just gonna make it an array that has 2 things in it.
Sure.
Let's just say this is the carryover. 0 means no carryover.
Well, then you cannot say number 1 is null, because number 1 will not be null anymore, because you changed the structure. We need to change.
Number 1 is null.
Because okay. Because we didn't change the data structure that's of the argument, we just changed the return statement. Okay, keep going.
Okay. Okay. So, but we do have to change how we handle the result, because result is a different thing now. And in this case, I guess it's okay. This is the one where we would have to handle the carry. But let's fix the rest of the code first. We want to grab the 0 thing from the result. I guess if there is a carry, that should be added to digit 2. And since we're gonna make it a number, we could just always add it. How about that?
Sure.
Like that. We're always gonna add it. If there's no carry, it's a 0, and that's fine.
Oh.
And then here we do the same thing here.
Okay.
Here we have to check for the carry. I guess the carry would be, we divided by 10. Yeah, divided by 10.
Yeah.
Divided by 10, and we will want to round it down. Oh, do I have this function?
Well.
Does the programming language have this function? Let's see.
But does it have to be that complex? because we're only gonna carry one, right? I mean, is it possible that we're gonna carry like more than one?
Oh, you're saying we don't have to do of divided by
Yeah.
10? We
Is
can
that-
just if
I mean,
if it's greater than 10.
10.
If it's greater
Yeah.
than 9 or greater or equal to 10.
Yeah. I mean, we're not gonna carry two. Like,
So if result number is greater or equal to 10, then carry is 1. And result number is result number minus 10. And then, okay, so we change the result number. Now it goes in here. All right, let's try this.
Get the debugger to help.
So we're just gonna go over it and see what the result is. It's 807. I think that's correct. Yeah, it's 807 is what it's supposed to be.
I like to talk about how I can get the stuff running.
Okay, sure. This is the open source project Playlang where all of this work is happening right now. So what you do to get started is you clone this repo. You click here and you clone it.
Okay.
And then you go in there and you npm install like you would normally do. And then after that, oh wait, maybe I should write it into the readme. Oh, you may need to gen parser actually. I think you need to run this. So npm run gen parser, run this gen parser script. So npm install npm run gen parser, and then I believe you can after that you can start using this run script, which you would type /run and then the name of one of the examples. So you can just try something from the example folder, like ex/fib.play. Try running that. And then if it works, then you're ready to go. And then you can also start debugging it. And when you debug, make sure you give the debugger the history file, not the code file. And if that works, then you're set up. There it is.
I will give that a try.